Hi everyone. Today we are studying section 5.3, the Fundamental Theorem of Calculus. This is one of the most important ideas in all of calculus because it connects two big concepts we've been studying, derivatives and integrals. In this section, we are going to explore that relationship and learn how to evaluate definite integrals much more efficiently. These ideas allows us to evaluate definite integrals without using Riemann sums. Connect differentiation and integration. Find derivatives of integrals and solve real-world problems involving accumulation, such as area, distance, and total change. This theorem is one of the most important results in calculus. So what we are learning here is a big deal. Before we get to the fundamental theorem itself, we need to understand an important idea called the mean value theorem for integrals. If a function f of x is continuous on a closed interval from a to b, then there exists a number c in that interval such that f of c equals 1 over b minus a times the definite integral from a to b of f of x dx. Let's break this down. This expression on the right represents the average value of the function over the interval. If we multiply both sides by b minus a, this cancels out. We end up with this formula. The definite integral from a to b of f of x dx equals f of c times b minus a. Here's what this means. There is some point c where the function equals to its average value. So the function actually reaches its average height somewhere in the interval. Let's interpret the pieces. 1 over b minus a times the definite integral from a to b of f of x dx is the average value of the function. And c is the point where the function equals that average value. So overall, this theorem describes the average behavior of a function over an interval. Now, let's apply this idea. Find the average value of the function f of x equals x over 2 over the closed interval from 0 to 6. And then find the value of c where the function equals that average. So we want to find the average value of the function, and then we want to find c where f of c equals the average. So first, let's find the average value of the function. The formula for the average value of the function is 1 over b minus a times the definite integral from a to b of the function f of x dx, where b equals 6, a equals 0, and f of x equals x over 2. The definite integral from 0 to 6 of x over 2 dx is the area under the curve from 0 to 6. So first, let's sketch this on the graph. This is a linear function. When x equals 0, f of x equals 0. When x equals 2, f of x equals 1. When x equals 4, f of x equals 2. And when x equals 6, f of x equals 3. So this red line is the graph of f of x equals x over 2. And we want the region under this line from 0 to 6. So we want this area. The area of this shaded region is the definite integral from 0 to 6 of x over 2 dx. And this is a triangle. To find the area of a triangle, I use 1/2 times base times height. My base is 6 and my height is 3. So I have 1/2 times 6 times 3, which is 9. So the definite integral equals 9. So the average value of the function is 1 over 6 times 9. 1 over 6 times 9 is 9 over 6, which is 3 over 2. So the average value of the function f of x over the closed interval from 0 to 6 equals 3/2. What does that mean? 3/2 is here. So this is the function value from 0 to 6. The minimum is 0. The maximum is 3. The average of the function value is 3 over 2. So this is just the average of the function value from 0 to 6. The next question is, we want to find the value c where the function value at x equals c is 3 over 2. So this is the average function value, 3 over 2. And we want to find the c value where f of c equals 3 over 2. So this is f of x, and this intersects 3 over 2 at this point. So at this value, f of x equals 3 over 2, and that value is 3. So when c equals 3, the function value is 3 over 2, which is equal to the average value of the function. We can also find c by setting f of c equal to the function's average value and solving for c. All right, f of x equals x over 2. So f of c equals c over 2. The average function value was found in the previous step, which is 3 over 2. And to find c, I multiply both sides by 2. So I have c equals 3. So what does that mean? It means that when x equals 3, the function reaches its average value over the interval.